Hi, welcome to Advanced Ionic Naming and Oxidation Numbers. So a little bit of this is going to be review to get us back on track with how to make correct ionic compounds. So we first want to go through and look at what we have as our reactants and determine what is the charge of each of these ions in the ionic compound. Sodium would be +1, chlorine -1. Silver is a transition metal, but it has a unique charge of +1. Nitrate -1. You need to recognize your polyatomic ions, ammonium and nitrate. Sulfate is 2-. Now copper does have different charges depending upon being copper 1 or copper 2. However, because sulfate is 2- and there's one of those, copper must be 2+. We'll get to more examples of that later. Calcium has a 2+ charge. Chlorine has a minus charge. Nitride has a 3- charge. And because there's one nitrogen ion with a 3-, that means this has to be 3+. Now, positives attract negatives, and if these are to react, a positive ion must now react with a new negative ion. So that means we're going to have sodium and nitrate make a new combination, and silver and chloride make their combination. Now remember, to get the correct compounds, we would cross the charges from the superscript, which is on top, to the subscript. So remember, this is, I'll use a different color, 1 down here, 1 down here. So that means we have NaNO3. Likewise, a charge of 1 down here, a charge of 1 down here. Zoom out a little bit. That will give us AgCl. I'm not going to worry about balancing and those kinds of things just yet. We're going to look at just making on these complete chemical reactions. Likewise, when we come down here, copper has a 2+, is now going to be paired with nitrate, which is a 1-. Crossing the charges, coming down, means I have copper and 2 nitrates, which I need to put in parentheses to illustrate I have 2 nitrate ions. On the other hand, we have ammonium, NH4, with its 1+ charge, sulfate with its 2- charge. Crossing the charges down, and that's going to give me 2 ammoniums and 1 sulfate. Coming down to the last one, so we have calcium with its 2+ charge. That's going to be paired with nitride with its 3- charge. Again, superscript becomes the subscript, and that's where I'm going to get calcium 3, or Ca3N2. And if we're looking at iron with its 3+ charge, that's going to be paired with chlorine with its 1- charge. Again, superscript down to the sub. This is where we get iron 3 chloride. We'll talk about naming in just a moment. But these are completions of what's called a double replacement reaction. The ions are just going to form together new pairings. And these new pairings are going to be paired with correct chemical formulas based upon their charges and this crisscross method we talked about before. Alright, let's take a look at going from the name of a chemical compound to the chemical formula. Take a moment to copy down the rules. Go ahead and pause. Now let's take a little bit of the work for here. So let's focus on the no transition metals. You write the cation, then the anion, and then cross to reduce. So calcium is a 2+ ion. Bromide is a 1- ion. Crossing the charges, we get CaBr2. Strontium with its 2+ ion. Carbonate is a polyatomic ion. Expect you to know where to find that. Cross the charges, and that gets us our SrSO3. Because remember, we have to reduce it to lowest common ratio. Lastly, lithium with its +1 ion. Acetate CH3COO, 1-. Crossing the charges, you see that they'll just come together as our lithium acetate. Now when it has a transition metal, you're told the unique charge by that. So it's actually much simpler because you don't even need to memorize what they are because it tells you. So for example, iron is telling you it's 3+. Sulfide is for sulfur, that's 2-. So crossing the charges, we get our Fe2S3. Iron sulfate, in this case iron has a 3+ charge still. Oops. Sulfate is SO4, 2-. Crossing the charges, I can see I get Fe2 and then SO4 subscript 3. The last one, vanadium oxalate. I feel like I've ran out of room. I'm going to do it over here. Vanadium with its 5+ charge. And oxalate is not oxygen. I'm looking at my periodic table on the back. I see oxalate is C2O4, a nice polyatomic ion, and it's 2-. Double check that. Yep. So crossing the charges, I get vanadium with 2 of those, and then our oxalate, again in our parentheses, crossing down the charges there. So again, crossing the charges is how we get there. You need to know the charges so you can cross them, and there's a couple different ways to go about that depending upon if it's a transition metal or a regular one. So as you see, transition metals can have unique or differing charges depending upon your point of view. Now, to determine the charge of this is the procedure at which you would go through in order to do so. So take a moment to write it down, and I'll show it to you in action. All right, so let's take a look. So if you're looking at this, you have to determine the negative charge of the anions. So each oxygen anion is a -2 charge. And because there's 3 of them, that means the total negative charge is 6-. Because we have manganese, I'm going to modify this to Mn2O3. Because we have 2 manganese, that means each of these need to have a 3+ charge, because 3 times 2 is +6. All compounds have an overall charge of 0. So you need to determine total negative charge in all collective anions and divide that by how many cations are present, and that is your charge of this. So this would be manganese. The charge I've seen is that each of them contributes a 3, and oxygen becomes oxide. Alright, so we have some rules here for determining what you would do for these. You might want to jot these down, even though it doesn't seem like I put it on the notes page. But they're very simplistic. So let's take a look if you have no transition metal. Name of the cation, then the anion. So we always call the first one is just whatever it's given as, its elemental name. So that's potassium. And phosphorus becomes phosphoride. Aluminum, oxide, because again you're just putting the two different ions together, and magnesium bromide. So very simplistic, don't need to determine the charge, it's very direct and straightforward. Now, here we need to know the charge of these. So again, I'll kind of go through our little math that we have. I'll do that first for all of them. So chlorine has a -1 charge, which means total there's a 3- charge, which means there needs to be a 3+ charge. Because there's only one iron ion, we know that its charge is 3+. Nitrate, its charge is -1, so overall negative charge is 2-. Again, because copper only has one present here, that means it needs to be a 2+ charge in order to cancel out the 2-. Phosphorus has a 3- charge, so that means this nickel needs to have a 3+ charge. Again, if there was, well, there couldn't be two, if there was 3 nickels present, maybe we'll change that. Oops, erase. Let's start over with this one. So let's say I had Ni3P. So phosphorus always has its same negative charge of 3-, which means the total positive charge would need to be 3+. Because there are 3 of them, that means nickel has a +1 charge. So once I've determined that, then it's going to be just using it with Roman numerals. So we have our iron 3, because that's the charge of iron, chloride. Copper has a charge of 2 in this case, and NO3 is nitrate. Be sure to use your reference on the back of your periodic table. Nickel has a charge of 1, so therefore, and phosphoride, in order to get our naming down. These are the rules for oxidation numbers. This is taking the idea of the Roman numerals and applying it to all elements. You've seen it with the transition metals, but this would be applying it to anything and or everything. Also keep notice that ion charges are the number then the charge. For example, 4-, 2+. Oxidation numbers are the charge and then the number, -3, -2, -1, +6. Keep those in mind when you're writing the difference between the two. Take these rules, summarize them as your own. They obviously give some examples, copy them if you'd like or not, but you need at least the rules. You need to be able to apply the rules to the ones given in this Ed puzzle, so take a moment to copy them down and then answer the following questions using these rules to look at and come in with your questions. Hope to see you soon. Bye-bye.